I actually remember when I went to, I don't even want to say I went to college in Vermont because I just went to have fun. I mean, it's college. So I did like 1 year in Vermont. And all I knew was
Okay. So how did clinic go? Your second week?
wow.
Boring. What? Oh,
Friday. I can get it,
Maybe I love kids.
No, I didn't. So where you going this week?
all right. So we're still missing a few people, but we're gonna go ahead and get started. So, after, when we get through with AEC, I'm gonna go over, test 3 on contrast, so that, we can look at that. Make sure there's not any questions there. We are in week 10, I think I just counted. The fall break next week.
And my birthday.
All right. So, it's a little late for a fall break, but that's the way it is every other year because of election day. Fall break falls with election day. So that happens every couple of years. Yes.
Lisa's on her way.
Okay. Hello.
I mean, I'm sure she.
Okay. Now you did not have Rad Tech boot camps due last night. You don't have Rad Tech boot camps due this Sunday night either because of the fall break. I'm giving you until the following Sunday to do AEC 1 and 2. So, so you get another week of no Rad Tech boot camps. So that works out nice. But they will be very helpful to you. So originally, I think we were testing on AEC before fall break, but then when the hurricane happened, it brought everything back. So, but it'll just actually give you more time to study for AEC, an extra week really to study for AEC. So, all right. So I love teaching about AEC. I think it's very interesting and it's a great tool that we have to use in clinic. You've probably already been using it. Did you realize you were using it already? Y'all figured that out? Because a lot of times, well, we'll talk about APR today too. A lot of times all we're doing is choosing a body part, right? That's the built-in technique chart that we're going to talk about here with AEC. So let's get moving on this. Here are some of the objectives, some key terms that we're going to learn, state the purpose of the AEC, talk about the different types of detector types. And so when we use this word here, we're not talking about our IR detector. We're talking about those little detectors that you can see on like the wall bucky. Some rooms it almost looks like Mickey Mouse because it has circles and then a square or a rectangle. You may have seen that. And we're going to look at how patient and exposure factors affect the response of the AEC. That's going to be a big part of what we do, especially in lab this week. And then talk about the difference between AEC and APR. And I believe that Alicia and I had a little bit of this discussion. I think it was you on Thursday. How they are not the same thing. It is two separate things, and how AEC can be a part of APR. And it is really dark in here, so y'all gonna have to try really hard not to go to sleep because the days are getting shorter. So we're gonna be getting here in the dark, and on Tuesdays leaving in the dark for those of you who have that late lab. So AEC defined. A device that automatically stops the exposure when a predetermined amount of exposure is reached. And generally that's going to be around 1 MR or if we're using the newer units, 0.01 milligray air. Have a little A attached to that. So you're going to hear this, and we're going to talk about this over and over and over again while we're talking about AEC, talking about meeting this preset amount of exposure or a preset charge that sends a signal to the timer to shut off. That's a big part of understanding how the AEC works. And so on the control panel, this is actually one of our older Philips rooms. Well, it is an older Philips room. But you can see, and so you may have seen a control panel. Anybody been out there in clinic and seen a control panel that looks like this? If you were at, let's see, the POA, so Piedmont Orthopedics, for either of y'all at Piedmont Orthopedics, they have it, were you at Greenville? Stephen Hawkins? Okay. So this should look familiar to you. You can see that for using AEC, you have to have it right here are the field. You're going to hear these called different things, and that's on another slide, but your detector or fields or photosensor selections, that's what you have to have here. And then this AEC button would be on when you're using AEC. Right now on this control panel, the AEC is off because what method of exposure, can y'all see that? What method of exposure is this that's activated or on right now?
Tabletop.
Tabletop. And so we're going to see we cannot use AEC on tabletop, right? There's no possible way because the radiation detectors or sensors or chambers or cells or field selections, all of those are talking about the same thing. It's talking about those sensors that are built into the table or the upright vertical bucket. So that's why we can't use AEC with tabletop because we are right on top of the table. There's no way to have that built in to, well, there is, but we'll learn about that next semester. It's not exactly the same thing, but some of our newer detectors have some technology built into them that's very similar to this. But when we talk about these things, we're talking about the amount of radiation that actually interacts with those and receives a certain amount of exposure and then sends the signal to the timer circuit to cut off. So radiation is transmitted through the patient. So that's the exit radiation, that radiation that makes it through the patient. It's then converted into an electrical signal that terminates the exposure when a predetermined amount of radiation has been detected. And this is calibrated by service personnel after much testing. So there's very specific testing that goes in to making sure that your AEC system is calibrated correctly and is working correctly and is sending signals to cut off when it's supposed to. So these radiation detectors, there's generally two types. We have photo timers, which is an older term. It's older technology, but you're going to hear a lot of the older techs like me still say, let's photo time that. When we say that, we mean let's use the AEC. So it's older term, but again, we sort of use it interchangeably, even though it really isn't. So we have photo timers, which again are more uncommon these days, or ionization chamber systems, which is more of what you're going to see today. So here, the sensor, instead of the X-ray timer, determines the length of the exposure. So with AEC, setting a mass is taken out of our hands. Does everybody see that? So all we're setting when we use AEC, we'll set a KVP still because we still got to tell it, what KVP we want to use. But instead of us manually setting a mass value when we're using AEC, it takes that away from us and does it automatically when this preset amount of charge is met. So that's why we say it's automatic exposure control instead of us manually setting an MAS for particular part. So the current produced inside the sensor charges the X-ray timer, and when a preset amount of charge is reached, then the timer cuts off. So it's looking for a specific amount of charge. That is preset. It's told, hey, whenever you receive this amount of charge or this amount of signal that charges that timer, then cut off. Okay, so with the photo timer, this older technology, there was either a photomultiplier tube involved or some kind of solid state photodiode. Both of these use a fluorescent screen and convert visible light energy into electrical energy. I'm going to show you a picture in just a second for you visual people. It is an exit type of device because the detectors are positioned behind the IR. So the timer is tripped again when a predetermined charge has been received. So for the photo timer, you can see that you have your primary radiation being directed at your patient. You have your table, and then you have your image receptor right here. And then you have these light paddles with the photomultiplier tubes that measure radiation exposure after it passes through the cassette. So while we call this an exit type of device is because it is measuring what makes it through not only the patient, but what makes it through the IR. Okay, so there's still going to be radiation that actually makes it through the IR and then will expose these light paddles. Hello. And then that will be what charges that photomultiplier tube and sends that signal to the timer circuit to cut off. So again, this is older technology. There may still be a few really old rooms out there in some of the older, clinic sites, but typically this is not going to be the technology that's out there. It's going to be this ionization chamber system. So they are a hollow cell that contains air and is connected to the timer circuit. So these are very similar to our dosimeter that we use. So you know the dosimeter that we've been using to measure radiation on some of our activities, the little thing that we sit down and get those readouts, is very similar to that. So we call it an entrance type of device because they are positioned in front of the IR. So these type of chambers are above the IR, whereas the older photo timers were beneath the IR. So when that chamber is exposed, the air becomes ionized and creates that electrical charge. And again, do you see how many times we've already said this statement, this last statement? When that preset charge is reached, then it sends the signal to turn off the timer. So it's all related to how long it takes for that preset charge to be met. That determines how long your exposure time actually will be. So here is a picture of it. So if you have your primary radiation directed at your patient, then see how the ionization chamber lives above the IR with this type of technology instead of beneath it. The bottom line is, and this one is just a comparison picture so you can see each side by side. So on the left, you have the older photo cell type of technology, and on the right, you have the ionization chamber. The bottom line is both of them are going to send a signal to the timer switch to shut off when a preset charge is met. So the general function of either is to do that. So instead of us setting the mask, it's going to send that signal when that preset charge is met, and that's what's going to determine how long the exposure lasts, depending on what body part you're doing. We're going to talk more about that here in just a minute. So what is the exposure level that is needed? Well, generally it's about 1 MR for a 200 speed class. Now, I know y'all don't understand 200 speed class right now, but I do want you to highlight this, circle it, underline it, whatever, because you will need to know this. And this all goes back to film. Okay. So with film, about 1 MR would put our, what we called our density across that film in a range that was visible to our eyes. It gave us an image that we could see all of the parts. They weren't too dark, they weren't too light. It was sort of that Goldilocks. It was just right, right? 1 MR did that with film. So they just stayed with that because that was a way to, we could measure that, say, okay, as long as the IR is receiving about 1 MR, then that image is going to be good. In other words, it should put your EXIs or your exposure indicators within your range that you want them to be in. Again, calibrated by service engineers with help from techs and radiologists. So we'll talk a little bit more about calibration stuff in just a minute. So hopefully you have noticed that even when you're using AEC, as soon as you make your exposure, what comes up on the control panel? It's in big bold letters up there. A mass, right? So as soon as you shoot it, you'll begin to notice. You may not have known to pay attention to that. But at this point, what I want you to start doing is, as you're using the AEC out there in clinic, pay attention to the fact that as soon as you make your exposure, a mass value will pop up. And that's the actual mass value that you got based upon how long your exposure time lasted. Okay? So it displays the actual amount of mass used for the exposure. Sometimes it only stays on display for a few seconds. So some of your equipment, it'll flash up there and then it'll be gone. Other equipment, it'll stay on there until you set up for your next picture. So by paying attention to that, you can begin to learn your mass values. So that if you are working in a place that doesn't use AEC, or maybe your AEC is not working for whatever reason, you have an idea of, you know, what mass values to set for particular parts. So the basic understanding, the goal. So several years ago, I was walking through Dollywood. You might have been to Dollywood. Dollywood's great. I love Dollywood. And I was walking through Dollywood along about the first part of October. So right before it was going to be time to teach AEC. And I was looking at this game. Y'all know these games where you shoot water and the goal is for you to get the water to the top fastest, and then you win. And I thought that is really a good analogy, I think, to help you understand what's going on with AEC. So we're going to look at each one of these sentences independently here. So the goal is to reach the top, meaning with the water shooting out of the gun. That's what we're going to refer to as reaching the preset charge of the AEC. So that's the goal. The goal for AEC is to reach that preset charge so that it can send the signal to turn off. The target represents the photocells or the sensors. So, you know, in the middle of this little thing right there is the target that you're shooting for, right? So in this example, the target's going to represent your photocells or your sensors or your detectors, fields, whatever you want to call them. Does everybody know what I'm talking about there? You've seen those on the like the wall bucky, and some rooms only have 3, but some might have how many? How many have you seen out there? 5. Somebody said over here 5. So it just depends on the type of equipment that you're using. How long the water is on is going to represent the time of exposure. And then how much water it takes to reach the top represents the preset charge. So let's look at what affects how long it takes to meet that preset charge. So part of this now is going to be review of what we already know to be true about some things. MA is one of them. So any MA may be selected when using the AEC. Now, you may or may not have the ability to set the MA. our equipment actually, remember, we can't. With this Siemens room, we can't set an MA. So that's done in the background. So you might be able to set the MA station, like just adjust the MA. Typically, you want to select a higher MA so that the exposure time is as short as possible. So isn't that something we've already learned? Why do we typically, if we're setting a manual technique, why do we typically want to set a really high MA if we could and have a low time? What is the benefit of that? Lower exposure time.
Less time to move.
Yes, less time for the patient to what? Move. So it reduces the chance or the opportunity for the patient to move and possibly put motion on your image, or move and you then clip something, clip anatomy or something. Okay, and if you are using a small focal spot, you have to stay within the MA range for small focal spot. So again, some of these things don't apply to our Siemens equipment because we can't set MA on ours. But if we could, if we were wanting to use a small focal spot on something, then we just have to make sure we kept our MA low enough to be able to do that. So how does changing MA affect the AEC? So let's think about it in terms of how big the stream of water is represents the MA station selected. So a bigger stream of water. So again, think about the little guns that are shooting the water out. Sorry. Sorry, y'all. We were wondering why my grandson, when he was about 2, would go at us when he got mad. I figured it out because I do that all the time. It's like, you can't do that. And then one day in class, I huffed like that and I realized why he does it. Anyway, so a bigger stream of water would represent a higher MA. And that means that you're going to reach the top quicker, right? You're going to meet that preset charge quicker. So if I have one gun, right? And Avery is sitting next to me and we're battling, right? But my stream of water is much bigger than his. I'm going to win, right? I'm going to get to the top faster. And that's the same thing that happens when if you have the ability to set a higher MA station when you're using AEC, then if you set a higher MA station, it's not going to have to stay on as long, right? It's going to reach that preset charge quicker. Does everybody follow that train of thought? Okay. Because we're not going to be able to prove this one in lab because we can't change MA, so you got to think about this one. All right, so think about it in terms of this. Everything that the AEC is doing is what we would do if we were setting it. Okay, so the AEC is just replacing what we would do. So if we set a higher MA, then our time can be lower, right? So if we set a higher MA using AEC, then it's just not going to have to stay on as long. The signal is going to be sent to the timer quicker if we have a higher MA. Does that make sense? Because we have a higher current, right? Remember, MA controls current. So if we have a higher or a bigger current, then that means we're going to have more what boiled off of the filament? More electrons boiled off of the filament. So your exposure time wouldn't have to be as long if you have a higher MA station set. So stop me if you have questions. So matter of fact, I meant to say this at the beginning, but I'll say it now. So this week in lab, we're going to do these AEC activities, okay? You're going to have a quiz that you're going to be given. It's going to be open book, open notes, open PowerPoint, just not open math, okay? So any of these notes that you're taking today during lecture, any of the notes that you take while we're doing the activities in the lab, you're going to be able to use for this quiz that I'm going to give you. It's like it's in chart form, And it's going to be a really good study tool for you to have. So make sure you're taking good notes, especially while we are doing the activities this week. Okay. So KVP, we still know that optimum KVP should be used because KVP controls subject contrasts, right? We talked about that for the last 2 or 3 weeks. Changing the KVP with AEC does not affect brightness. It only affects the time of the exposure. So it does not affect brightness. It does not affect receptor exposure. Okay, brightness is what represents receptor exposure. So brightness meaning the representation of receptor exposure. So for example, if we increase the KVP, then the exposure time is going to decrease to maintain exposure. So what we're saying is, if we increase KVP when we're using AEC, so we have our field selected and our density setting and all that, and we increase our KVP, then that is not going to affect receptor exposure, because in the background, what is going to happen to our exposure time? If our KVP goes up, think back to the last couple of weeks. If our KVP went up and we wanted to maintain receptor exposure, what did we have to do to mask?
It goes down.
Yes. So if we were manually setting a technique, right? And I'm picking on her because we had this discussion this morning, so don't think I'm like putting her on the spot. So if KVP goes up when we're manually setting a technique, our mask goes down. If the objective is to keep receptor exposure the same. So the AEC is going to do the same thing through the time. So if we increase KVP, then it's going to meet that preset charge what? Quicker or take longer? Quicker. So the time is not going to stay on as long. So because our time is not going to stay on as long, our mass value is not going to be as high. Okay, which is what we would do if we were manually doing that. Is everybody following? So how the KVP affects the AEC, think about how strong the stream of water is representing the KVP selected. So a stronger stream of water, if I'm babbling here, a stronger stream of water, higher KVP, is going to reach the top or meet the preset charge quicker. Okay, so higher KVP means that preset charge is going to be met quicker. My time is not going to stay on as long, but my overall receptor exposure is still going to be the same. So unfortunately, there's a lot of techs out there that don't really remember, and I'm not faulting anybody when I say stuff like this, because if I wasn't teaching this stuff every single week, I'm not going to remember all of this, just pretty much on the day-to-day. But a lot of people don't remember this. And if they're using AEC and their image is underexposed and they increase that KVP, they're not really doing anything. They're not really doing anything to help that problem. Because what the AEC is going to do is it says, okay, the KVP is higher, so I'm just going to meet that preset charge quicker and the time's going to be shorter. It's not going to change the overall receptor exposure. Does everybody follow that? We're going to talk about it more when we get to lab. So when you see if the text says, that's underexposed, and they crank that KVP up or whatever they do to the KVP, and they're using AEC, it's not going to help. Not unless they look at it and say, oh, that is underpenetrated. Like the thickest part is not penetrating. Remember those examples that we did in lab of the area behind the ears? So that's a different problem. But if you are using an optimum KVP for a part, then increasing that is not going to change your overall receptor exposure. Okay, so now we've talked about how changing MA affects AEC. how KVP affects AEC. Now let's talk about the anatomy being over the sensor. So if there's something in front of your target, it will take longer to reach the top or reach the preset charge than if there's nothing in front of it. So again, if me and one of y'all are battling out, you know, we're trying to see who can win this race, then if something is put in front of my target, you know, when I'm shooting the water, is it going to take me longer to reach the preset charge than if there's nothing in front of the target? Yes. So think about that as being anatomy. All right. So if there's anatomy in front of the detector or the sensor or the photocell, whatever you want to call it, then it's going to have to stay on longer, right? It's going to stay on longer. It's going to take longer to reach the preset charge than if there's nothing or little over the sensor. So your method of exposure is extremely important. If you're shooting at the wrong target, so for example, and I'm pretty sure our new rooms will not let us make this mistake, which is good, okay, because you can really do some overexposing to some patients. But there's a lot of rooms out there that will still let you make these kind of mistakes. So what this is saying is if you're shooting at the wrong target, so in other words, if I have the wrong method of exposure selected, so let's say I'm doing an abdomen in the table bucky, but I have wall bucky selected. Okay, so wall bucky is selected. So those sensors or those detectors are the ones that are sitting there ready, right? They're buckets. You're going to see that on the RadTech boot camp. It talks about those sensors as being buckets. And I love that analogy too. They're sitting there waiting to get filled up, those buckets. So those buckets over there are the ones that are ready, right? Because I'm telling it, hey, I've got wall bucky selected, but I really needed to have table bucky selected. So here it would be like if I'm supposed to be shooting at Cody, because that's my target, but I'm shooting over here at Emma. Is this ever going to fill up over here if that's the photocell that I have selected? No, because I'm shooting over this way. So this is the same thing. So if I am directing my beam down at the table, but I have wall bucky selected, are those buckets over there going to fill up? Nope, it's just going to stay on and on and on. That time, that exposure is going to stay on and on and on until it hits what we call a backup exposure. And we'll talk about how big that is with most rooms these days because we don't have the ability to set a backup time. So this patient is receiving all this radiation for nothing, right? Because these over here are waiting. Now, our rooms won't do that. It won't give you a green light. If you have the wrong method of exposure selected to where you have the detector, it's going to give you the error. You know, the little errors that you get that tell you why you don't have a green light. So it tries to keep us or prevent us from making big mistakes like that. But some rooms will still let you do that. So make sure. This is why we tell you to start with the method of exposure when you are setting your techniques. Besides the fact that with our equipment, if you don't, and then you realize it, what does it do? It changes everything. So as soon as you hit the one you're supposed to be on and you've set everything, it redoes everything. So besides the fact that it's inefficient, it's very important because it can keep you from making a big mistake. So minimum response or reaction time. See that it is called two different things. Minimum response time or minimum reaction time. So that is talking about the shortest time that it takes for the photocells to stop the exposure. Meaning it's the length of time necessary for the AEC to respond to the signal to turn off. So it is the shortest response time that your machine has. Like, you know, we all have reaction times to things, right? So whether it be to, you know, somebody throwing a ball at your face, and how quick can you get your hand up to keep the ball from hitting you in the face? So this is sort of like that. It's the shortest time that the machine can actually react and cut off. So usually it's about 1 millisecond on today's newer units. So that's very, very, very short time, right? On some of the older units, it could be as much as 50 milliseconds, right? So even though 50 milliseconds is still short, it's not short enough on some cases, okay? So minimum response time can be a problem if your exposure time needed would be shorter than that minimum response time. Then it can't turn off fast enough, but no signal to the operator. Sorry. So what this is saying, let me see if I have another. Okay, so what this is saying is, let's say we have an older piece of equipment and the quickest that it can cut off is 50 milliseconds. But let's say we're doing a little elderly patient, and really and truly, it would only need to be on for, say, 20 milliseconds. Do you see how that's a problem? It really needed to cut off at 20 milliseconds, but it can't, because it can't get its hand up there fast enough to keep the ball from hitting them in the face. All right, it has to go to 50 milliseconds before it can cut off. So that's where it becomes a problem. So that's why the newer machines have like an MRT of about 1 millisecond, because pretty much that's going to cover everybody. That's a pretty quick response time. Okay. Any questions about this? For some reason, this concept a lot of times is not real clear to students. So I want to make sure that everybody understands it and that there's two names for it, because y'all know how I like to put those kind of questions on the test, right? So it can be known as either minimum response or minimum reaction time. Okay, so backup timers. If your equipment has the ability to set a backup timer, that's great, because it can keep you from really overexposing a patient if you make a mistake. It's for patient safety. It's also for equipment safety. Because when I was saying earlier, if I had the wall bucky selected, but I was really trying to do it at the table bucky, in that situation, if my room lets me shoot, look at how much mass it's going to run up to before it cuts off. 600 mass. That's a lot. Okay, that's a lot of mass. So we don't want that to run, but that's what the government requires. That's the cutoff. If your equipment has the ability to set a backup timer, your rule of thumb would be set your backup time to about 1.5 to 2 times what you'd expect it to be. And then if you make a mistake, they're only getting like, you know, let's say let's see if I have an example in here. So let's say, for example, your expected time, your expected mass value, okay? Your expected mass value for an abdomen is 20. On like the phantoms we've been using in the lab, you know, the acrylic phantoms, and on patients, 20 is sort of an average for an average size person mass. So let's say we're going to use, we have the ability to set a backup timer. Our equipment says, yes, you can do this. That way, if you make a mistake, you haven't really overexposed them to 600 mass. So what would our backup mass need to be if our expected mass was 20? What would it need to be? 40? It could be 40. It could be 30 to 40, right? Because we're saying 1.5 to 2 times. So if we could set our backup mass through the time to 40, then if we do something stupid, like we have the wall bucky selected, but we're really doing it at the table, then the patient would only get 40 mass instead of 600 mass. Does everybody follow? Now, our equipment does not allow us to set a backup time or backup mass. So if we made a mistake, it would run to 600 matched. However, our equipment won't let us make this kind of mistake because it's going to sense wherever the detector is, and it's going to not give us a green light if we don't have the correct method of exposure selected.
Okay, I have a question about that with our
Yes.
equipment. Because I know I've made the mistake where I say free detector and then the detector is not under it. Well, it's still,
Now, in that case, we'd have to test it, but it may still, because free detector, it's not, well, okay, so if you have free detector selected, but you have the detector in the bucky, it's sort of the same thing. You're not
Right.
gonna get a green light. Is that your question?
no, because I've done it where, because I know I've done this. And
Did you have it
just
on
shows-
free cassette?
Maybe that's what I did.
So free cassette, remember the difference. So free cassette means, let's say something's wrong with our detector and we have CR cassettes and we can bring those in and use them. That means you're not imaging on the detector that came with the system. You'd be using CR. Free detector is just, you're using tabletop, your detector, right? Like extremities. So in that case, it might let you shoot if you have
That's what I
free
was thinking.
cassette selected.
But I think it'll also let you shoot if you say tabletop, but you've got your tube over here and your detector's way over here and they're not lined
We can
up.
check it out in the lab.
Okay.
We can definitely check it out because I actually have something written similar to that in the lab unless I took it out. But so that we could see if we can make those mistakes in lab so that you can see what it's like instead of making them, but we can check that out. Any other questions? Trying to stay on track here. Okay. So your density controls, you've probably seen these and didn't even realize that they were part of AEC, but your density control is what permits the adjustment of the amount of radiation from normal amount programmed. So in other words, if your machine is calibrated correctly, then your AEC should be operating at a density setting of normal, okay? Normal, or you may see it as a 0, okay? You can change your density controls when normal positioning doesn't provide proper receptor exposure with the configuration of the cells that you're using. So the only way, and this is a statement that you need to write down, and we're going to say it again in lab, the only way to intentionally, all right, that's the key word. The only way to intentionally change receptor exposure when using the AEC is through the density setting. Okay? The only way to intentionally change receptor exposure when using AEC is the density setting. Because we've already said increasing the MA doesn't do it because the time just doesn't stay on as long when we increase the MA. If we increase the KVP, again, the time just doesn't stay on as long. Receptor exposure should stay the same in those cases, okay? So the only way to intentionally change it is to either use plus or minus density setting. So what that is doing is, so I know that image is terrible, it projects terrible up there, but the main thing I want you to see is the darkness and brightness of those images. So when we change the density setting, there's usually about a 25% change in preset charge between each setting, which is programmed by the service technician. So let's say, for example, this one in the middle was done on normal. All right, that's where we want it to be, normal density. If we use a +1, then it's going to add about 25% of preset charge. In other words, let's just talk hypothetically here. Let's say that normal density setting is, and this is not exactly right. Okay, this is not technically right, but we're going to use this example to help you understand what's happening here. So let's say at normal density setting, that bucket, all right, for a knee, because you're going to have just the single photocell selected, that bucket is looking for 100 photons before it reaches the preset charge and cuts off. All right, at normal, it's looking for 100. If we use a +1 setting, then that's going to tell it, hey, don't cut off until 125 photons hit that bucket. Everybody following me? So it's increasing the preset charge. It's increasing the amount of charge that sensor is going to look for, that bucket is going to look for before it sends off the signal to cut off. The opposite holds true in the negative. So if we use a -1 density setting, then we're saying, hey, cut off when 75 photons hit the bucket. Okay, so we're purposely, intentionally saying either stay on longer or don't stay on as long. That's the plus and the minus. Everybody following? Okay, so typically, if your room is calibrated correctly, you should be shooting things at normal density. However, being out in clinic the last few weeks, I've noticed that that is not the case on some things. And I'm not saying it's wrong. I'm just saying that you shouldn't be having to be on +3 density setting on the chest if your room's calibrated right. And that's the way it is in some places. When you choose the AEC and you choose, I'm coming to you, okay? When you choose the AEC and you choose chest PA, and it comes up, let's say 120 or 125 kVp, that's reasonable. And it's on +3 density setting. On an average size person, something's not right. But that's the way they have the room calibrated, and you go with it. That's what you use. But I just don't want y'all to get confused by that. So if that's the case, then that just means that that particular room, that's the way that room is calibrated, and you just use what they have programmed in there. Yes. So what was your question?
So I was just gonna say for every factor of 1 density, there's a 25%.
Typically that's the way it is. It is manufacturer specific, but in general, a +1 would mean you're adding about 25%. So a +2 would be 50%.
So for quiz and test purposes, we just go with that.
Yes. Yeah. And some rooms may have additional, like they may have a +0.5, +1, +1.5, +2. So they just have smaller increment changes, but it's going to be very manufacturer specific. All right, so anybody seen anything that looks like this? I know Patewood people have. It looks like this. Probably some of your Greer people may, I don't know. I'm trying to remember that room might be a little bit newer. But your typical cell arrangement is 2 outer and 1 center cell. So everybody sees the Mickey Mouse looking ears. Those are your photocells there. You won't see those on tabletops because they're not stationary. So in other words, the photocells or the detectors or those sensors are going to move with the Bucky tray in the table, right? Because most tables have what? That floating tabletop that can just go anywhere, right? Is everybody following me? So they're not going to put pictures of the photocells on the tabletop because you could have that tabletop slid all the way to the top or all the way to the bottom. So you're not going to see pictures of the photocells on the table, but you will on the wall bucket because that doesn't change, right? The top of that doesn't move. That whole thing moves as one piece. So that's the why you won't see pictures of the photocells. So selection of those photocells is vital to making the AEC work correctly. There's a couple of things that we're going to talk about that the AEC gets blamed for stuff that is not the AEC's fault. Okay, and this is one of them. So you have to select the correct photocells for the part that you're doing. So you're gonna select the outer two cells for the PA chest because they are away from the mediastinum and completely in the lobes of the lungs. So in other words, you want those two, the rounds in that case, that we were looking at earlier, we want the two outer cells because we want it reading over the lungs for the PA, okay? If we chose the wrong photocells, let's say we select the center photocell for the PA chest. We messed up and we didn't take it off of lateral from the last patient and we shot it, which we can't do with our equipment. But anyway, let's say we shot it on the lateral setting for the PA. So it's reading right through what? What photocell is selected if we have the center one? I mean, what anatomy is under that photocell? The spine. So if we select the center cell for a PA chest, then that is over the spine and the exposure indicator is going to show overexposure. Now, our digital systems, this is more of the way it would look with film, but I wanted you to get a visual, okay, of what would it actually be doing, because nowadays the software can correct so many mistakes, you can't get that visual of what you're actually doing. Do y'all see how this looks? You can tell this is overexposed, right? These patients' lungs are black. All right, so think about that marshmallow, that black marshmallow. The reason it's so dark is because that photocell that was selected, the spine is what is laying over it. So it's going to stay on longer, right? Because it's harder for that preset charge to get met when it's going through the spine as opposed to what? Going through the lungs. Is everybody following? So it stayed on way longer than it needed to. So really probably the only clue you're going to get is your EXI or your exposure indicator is going to show way overexposure. It may not look this severe. Your image, it might look dark, like you might have some saturation, but probably won't. All right. The other thing that we can do is for a lateral chest, we're going to choose that center photocell because it's over the thickest part of the anatomy. So instead of selecting the circles that part of it may be out here and part of it may be out here, we want to select that center one that's just laying right over the middle of the anatomy, right? Look how pretty that is. The only negative I have about this image is these arms should have been what? Up higher. They cheated and they just went like this. All right, so see how you have part of this arm skin hanging down, tissue. So, but look at there's almost no rotation on this chest. So if you're looking at that, you're like, that is good, right? We've included all the anatomy. There's almost no rotation, so those arms need to go up. However, if we accidentally had the outer two photocells selected instead of the center, it's going to be way underexposed and noisy. Do y'all see that? Because what's happened is we've chosen these outers out here. And is there even any anatomy over part of those photocells? No. So it's going to reach that preset charge really quickly. Thank you. Really quickly. It's going to send the signal to the timer to cut off, and the image is going to be underexposed. So these are the things that we're going to go back over in lab. We're actually going to make some exposures and let you see the actual EXIs and see what the images look like, because these are the kind of things you're going to have to know for that quiz. All right, so we're going to go over it all again. When more than one field is selected, then the exposure at each of the chambers is average. So if you have all three of them selected, which sometimes we do that for different things, sometimes places do that for abdomens, they choose all three, then it's just going to take an average of all of those. Patient centering is the other crucial factor when it comes to the AEC being used properly. So The anatomic area of interest has to be centered properly over the detectors that are selected. So, for example, proper AEC location and its effect on receptor exposure. So we have 3 different things going on here. Let's look. So if we are doing a lateral lumbar, no, y'all haven't had that yet, but this is a prime example of when you cannot be centered well and it affects your image and you possibly have to repeat it. That's why Delisha and Alice, Tracy was saying she sets her techniques on spine work. This is why, because she doesn't want to take a chance of not being centered perfectly and the image not coming out good. And there's other techs out there, I'm sure, that will say, I set my technique, meaning I set a manual technique on spine work, especially C-spines. I never use the AEC on a lateral C-spine because the patient has the opportunity to do what? Sort of sway, right? So if they sway too far forward and I don't catch it, like from the time I go out of the room to go around to make the exposure, they might have swayed forward too much. Now they're not centered over that photocell anymore. So it's probably going to cut off too quick and it's going to be underexposed. So this is a good example. So you want the part, the spine itself, and that is absolutely a lovely lateral lumbar spine. That is the way you want your lumbar spines to look. That's beautiful. But see how the centering, the positioning in relation to the photocell is right over the spine. That is what you have to have for your AEC to work correctly and give you an image that looks beautiful like this technically, right? The technical factor wise. Not to mention the positioning is perfect. It's beautiful. So if, for example, you have your lateral spine centered like this, do you see how the center photocell, the darker blue, that's the one we have chosen, right? So ideally, it should have been centered where? Right over the spine. Is it? No, it's centered over the posterior part of the spine. Therefore, not only are we clipping anatomy, so we have a positioning issue, but look how underexposed the image is. That's because we don't have as much tissue from our posterior spine to our skin line as we do in between there, right? So it's going to reach that preset charge too quick. It's going to cut off too quick. Our image is going to be underexposed. Is everybody following that? So selection of the photocells and centering are still our responsibility. And if we don't do those things right, then the AEC cannot work right. So don't be blaming the poor AEC if your image comes out and darn AEC and you're centered something crazy, right? Or you chose the wrong photocell. So the key to using the AEC effectively is know the location of the chambers, the ionization chambers, the little either circles or rectangles or whatever. Know how to precisely position tissue over the AEC location, meaning the thickest part should be over the photocell that you have selected, and know how to adjust collimation with AEC to avoid exposure problems. So again, the extremes. You don't want the collimation to be open so big that it causes you problems. You also don't want to be collimated so narrow that maybe you're collimating off part of the photocell. So the happy medium. So let's see here. What is this saying? Let's say you didn't center well on an AP shoulder and your image is noisy. So there's 2 things you can do. So let's say you just did not center the shoulder over the photocell like you should have, okay? And so it sent a signal to cut off too quick, so it's underexposed. There's a couple of things, couple of ways you can fix that. You can either repeat it based on increasing the actual mass that came up, or you can reposition and repeat. So remember how I said an actual mass will pop up after you shoot your first one? So let's say, for example, the mass you used was 8, and that's underexposed. Then you can manually set more mass and repeat it and not use the AEC on the repeat. Or you could center appropriately, repeat it, and then your mass value would go up because you would be centered over the thicker part. It would stay on longer. It would expose appropriately. So there's two ways you can fix it. Doesn't matter which, as long as you make enough of a change to matter. So some patient considerations. The beautiful thing about AEC is that it can generally compensate for changes in patient thickness, meaning thicker patients, the AEC is just going to stay on longer. And it can generally compensate for pathology, which is wonderful. So let's say you have a patient, let's see what else I got here. Okay. So let's say you have a patient for a chest x-ray that has emphysema, okay? And you don't know it, you didn't ask them, didn't take a good history. This is more of a film CR issue, but still your EXIs would be, would indicate this. So let's say you have a patient with emphysema and you don't adjust your technique when you're using setting an MAS. So for emphysema patients, we don't have to use as much mass. That's just something you're going to learn next semester because of the pathology. All right, anyway, you just don't have to use as much mass, okay, on a patient with emphysema as a normal lung patient. So if I didn't, when I was using film and I didn't adjust my mass value down from a normal mass value for this emphysema patient, my image would be dark, okay? With AEC, it's just not going to stay on as long, right? It's going to reach that preset charge quicker. It's going to send a timer signal quicker to cut off. So it takes care of it for you. So that is the beautiful part of AEC, is that it compensates for a lot of different things and takes that worry out of our hands, okay? If we have a thicker patient, then it's just going to take longer to reach that preset charge, so it's just going to stay on longer. It just won't cut off as quick. So again, really helps us to be more efficient when it's used correctly. So the things that you're going to have to know how to do to set the AEC is still set the KVP and the focal spot size, sorry. Set a backup time if applicable. Ours does not let us do that. Set the MA station if it will let you. Ours does not do that. And then set the appropriate density level, which ours does, and your sensors. So which sensors do you want to select for what body part? And we'll talk more about that today in the lab. Now, APR, anatomically programmed radiography. You have all already been using this and didn't even know it in clinic. It's just your program technique chart. It can be used with AEC, okay? But it can also be used when AEC is not on. So APR is all that is a programmed technique chart. Instead of having a paper chart where you're looking at it and you're setting your technique, you just choose hand and hand PA, and it comes up with a KVP and a mass for you, right? Or you choose chest, and it automatically puts it on AEC for you, where it selects 120 KVP outer photo cells for the PA, normal density setting. Okay. Let's see here. We talked about that. You can override the APR. So when might you have to override the APR? So let's say, for example, you're in an ortho site, okay? And you choose a hand or whatever. And the patient comes around with a cast. Are you going to use the same technique on a non-cast hand that you would for a hand with a cast? No. So you're going to override the APR and change your factors depending on, you know, the cast, type material, that kind of thing. Let's say that your technique is programmed for an adult hand and your patient comes around and they're 2 years old. Are you going to use what you use on an adult hand? No. So you're going to override it. So you still have to use your common sense and your critical thinking skills when using APR. Okay. So there are going to be times that you have to make changes to it.
Don't they have child settings?
They may. It
Okay.
depends. Some of them will, and some of them, like if it is a dedicated pediatric room, then those techniques set are going to be for peds. So let's say you brought an adult in there. you have to adjust it because those techniques are set for peds. Sometimes you can hit the body, there'll be like a little body part and a big body part, and that will adjust it some. But yes, it just depends on your equipment type. So AEC is great when used properly. Positioning of the patient over the sensors is critical. Most errors that occur with AEC are our fault due to positioning. And APR may or may not include the use of AEC. So AEC can be programmed in to the APR. Now, if you're like, oh my gosh, that was a lot, don't fret, because we're going to go over all of this again in the lab with these activities. And I think that it will come together for you when you actually see what happens and see the EXI numbers and get that visual of an actual, and we have rooms that actually work. 3 rooms that actually work. So that's going to be great. All right, so let me stop sharing and stop the recording because we are going to